Okay, for part B right now, that will be the distance of, calculate the distance x. So that will be from A to C. So the distance over here. So if we take out our equation of work and energy, so right now our case will be different because my point 1 will be A and my point 2 will be C. So the force or the energy, that will be from A, that will be from A to C. Okay, so we know that at A, that there is a velocity because just now we already calculate. So VA from the calculation just now, we basically it is obtained 2.13 meter per second from part A. And the question say the maximum distance of x. Okay, so the maximum distance of x. So when we're talking about dynamic, the maximum distance that means all the way the spring pulling the block back. Then, for example, I will make a small animation here. So from A, the block go to C. So x is reaching maximum. It is mean that he move all the way here, then he stop for a while and then bouncing back. Okay, so that's why he said that how many the distance actually travel maximum and then before he bounce back. So normally in that case, we will say that the velocity c, that will be 0, because before it bounce back, the object it tends to stop a while. So when the time it stop a while before he switch to the opposite direction, so we will assume that that particular point the velocity will be equal to 0. So that actually make the things much more simple, because if Vc is 0, then my T, the kinetic energy or Tc, that will be 0. And then I will simplify the whole equation as my kinetic energy at A, that will be m, the VA power 2. So m will be still 10, VA that will be 2.15 power 2. So, and then plus all the force over here, and then we know that the force will be still the friction force, and then at the same time that will be our spring force over there. Okay, but the spring force right now, that will be a C. So what I need to do is, of course, I will saying that this direction is still my positive. So my spring force C, that will be still positive. I can write that at that. So K, and then the traveling distance, that will be x maximum times x maximum. Okay, so this is the spring force, and this is the distance. So we all know that. If I simplify that, then that means my x maximum is just power 2. And then that will be minus my friction force times the distance. The distance also will be x max equal to 0. So things become much more simple right now because we want to look for the x maximum. And now we look at this calculation over here. So m is 10, then v will be 2.13 power 2. Okay, so that one we can resolve it. And then k, of course, we know that it is 300. And then x power 2 we don't know, that will be alright. And then friction, we know that it is mu times mg. So mu 0.3. And then m, that will be 10, and then g will be 9.81 times x maximum equals to 0. So if we resolve all this, we basically will get a quadratic equation. Okay, if you resolve all those things, so that will be something that look like this. Yes, that will be a quadratic if I'm putting 4 decimal. So if it is quadratic, then we can use the basic mathematics equation actually to solve it, using your quadratic knowledge to solve the things. So then you will have 2 answers for your x. So one that will be 0.34 meter, another one that will be negative 0.4. So because I know that my positive direction it is this, just now we all know that. So my x, if it is positive, that means that they will moving backward, and if it's negative, that means he's moving front. So that means this it will be moving back, and this actually will be moving. So if I want to look for the answer that is describing my situation, definitely the answer will be this. Because that's logic. I think it's moving backward. So by that, we also solve part B. And the distance, maximum distance that it will travel will be 0.304.